to get us, this is a logistic equation. So it's about growth that or decay that has kind of an S pattern, or I don't know, it's not an S pattern. It goes like this or the other way. It has a maximum. It has what's called a carrying capacity. Let me show you. Here's the notes. Here's the class notes for a separable equation. I'm sorry, for the logistic equation. And basically, it's when it has a carrying capacity, a maximum. So anyway, let's look at these equations, and I'll show you how we know. Do you see how there's a maximum right up here of 70? Do you see how it kind of caps out at 70? And it does that as you go this way. So as x heads to negative infinity, as x goes to negative infinity, the function goes to 70, right? As you go left forever, as we go left forever, this function gets really, really, really close to a height of 70 as we go left forever. As x goes to negative infinity, the function gets really, really close to a height of 70. So which function is going to do that? Well, let's take them one at a time. If we plug in right there, negative infinity, what's going to happen? You're going to get 1 plus 2.5 times 1.5 to the negative infinity. Got a 70 on the top there. Right, that double negative is going to make positive, right? We're plugging negative infinity right there, and there's a negative x. It's going to be positive infinity. So if you have 1.5 to the positive infinity, that's going to just go to infinity. So the bottom is going to become infinity plus 1. So the bottom will be 1 plus infinity, right? Because this is infinity times 2.5 is infinity. 1 plus infinity is infinity. 70 over infinity is 0. Right? If you divide by millions and millions of trillions, it's 0. Well, that's not right. As you go to negative infinity, you're supposed to go to 70, not 0. So we can't have a negative x down there. So that one's out, that one's out, that one's out. So we've only got three candidates left. How about this? I put in negative infinity there, then that'll be what? 70 over 1 plus 4.5 times 1.5 to the negative infinity. So that's looking better because that's going to be 70 over 1 plus what's that going to be? 4.5 over 1.5 to the positive infinity, right? Remember, a negative infinity makes you jump down below that item and then become positive, right? Negative powers are negative. They're unhappy where they're at and they want to jump to the other side of the fraction and then they become positive, right? So then this would be what? 70 over 1 plus 4.5 over 1.5 to the infinity is infinity. And so that's 70 over 1 plus what's 4.5 over infinity? 0. So that's 70. That's looking good. So this one, he's working so far. This one here, you put in negative infinity there. Oh, you're going to get 80 over 1 because this part will go to infinity, right? If you put infinity in right there. This part, you put infinity in right there. It's going to be 80 over 1, so he's out, right? We don't want 80 in the top. Put infinity in right there, and that's going to be 7. So both these two are working so far. They're the only two that when you plug in, oh, I'm sorry, we're supposed to plug in negative infinity, huh? Am I getting confused? I am getting confused. Let me try that again. We're supposed to plug in negative infinity. Anyway, but that is working. You plug in negative infinity, right? It jumps to the bottom and 4.5 over and then becomes positive infinity and 4.5 over infinity is 0. 1 plus 0 is 1. 70 over 1 is just 70. So, okay, but not 80. We don't want 80 over 1. So these two are good so far. Now, how do you know which one's right? The only difference is that one has, I'll circle it for you. That one has a 4.5. That one has a 2.5. How do you know which one's right? Plug in 0. If x, this is the point over 0, x is 0, what is the function? What is f or y? Same thing, function values or y values. Plug in 0, let's try this one. So you plug in 0, the function, plug in 0, you're going to get 70 over 0, 1 plus 4.5, 1.5 to 0. What's anything to 0 power? It's 1. So that's 70 over 1 plus 4.5 over 5.5. Divide that in your calculator. That's not 20. I don't know what that is. That's something else. It's going to be the other one. It's going to be Isn't it? I don't know. What is 70 over 5.5? Here, I'll go find out. I don't know. 70 over 5.5. Let's see. 70 over 5.5. 70 over 5.5. It's 12.72. 12.7. So this is 12.72, which is not right, right? At zero, it's supposed to be 20, right? So this one's out. It's got to be this guy. Let's prove it though. It's got to be this guy. How do we know? Plug again. Now plug in zero. You're going to get 70 over 1 plus 2.5. 1.5 to the 0. 70 over 1 plus 2.5. Because anything to 0 power is 1. Here, let's bring it down here. That is 70 over 3.5. And that indeed is 20. There it is. So that's the right answer. Oh, yeah, you can see it down here. That's how we discern this. So again, what did I do? I just looked and I said, as you go to negative infinity, as you go left forever, the function's supposed to come up to a height of 70. Plug in negative infinity for x, function should come to 70. So I tried plugging in negative infinity there, but negative, negative made it positive infinity. And that made the bottom infinity, and 70 over infinity is 0. So I had to cross out all the negative infinity ones. So I knew the regular x would work. Plug in negative infinity, that'd make that 0, and 70 over 1, 70 over 1 would be 70, not 80. So it's down to these two, and then I just tried plugging in 0. That one didn't work, so this is the 1. And so there we go. It's called a logistic equation. That's practice with a logistic equation.